Hi everyone, my name is Hadil, and today we'll do animated recursive subdivisions in Blender with animation nodes and Python. I really wanted to create Matt Taylor's animated recursive subdivisions in Houdini, but I don't have Houdini and I work with Blender, and I know a little bit of generative art, and I've created the recursive subdivision animation before in 2D form using processing, which is Java based, and it's very similar to what he created in Houdini using Vex. So let's get started. If you don't have animation nodes installed, then you'll have to do that. And I'm using Blender 2.92, and I think the latest for animation nodes is 2.2. And then I'll just open the scripting tab and we'll add a new panel. That will be my animation nodes. And then just create a new node tree, and I don't really care about naming it. And then I'll create a new script over here as well. We'll just call it recursive subdivision. So this is where we're going to do our Python. This is where we're going to do the animation nodes. If you've seen Matt Taylor's video, then you'll know that he creates the geometry here, and he has a bunch of properties that he can adjust, like time, noise, and of course X and Y for the values of the subdivisions. We'll be doing the same thing, but the code will be a little bit different because I figured that his way is not going to work in Blender with animation nodes, and it caused lots of issues. Okay, we'll delete the cube. Also, if you want to see the console, because this won't show you anything, I'm not sure if it does, but I researched it a lot, and the only way I could see my print results is if I open Blender from the terminal. Since I'm on a Mac, then it's for me terminal, but if you're on Windows, then it's the command line. That way you'll be able to see the console errors or whatever you're printing in Python in your script. Okay, we'll adjust the view over here. I'll just hit 7 so I can get the top view. Okay, the first thing that I'm going to add is create a grid. So I'll just do grid mesh, and then I want to do 2 by 2, and then I'll do mesh. Oh, and by the way, if you see this moving, then if you go to the node tree, then just remove or uncheck always and just check these, because we only want to see the changes when the tree changes, or if we add the animation, so if the frame changes or if properties changed, which is very important because we're going to use properties for X and Y, because always can crash Blender very quickly, and I also had my whole computer crash because of it. So yeah, always is not a good idea. And then I'll add a mesh object output so we can see what we're creating. So if I click this and, oh, we actually deleted, okay, I'm not gonna delete that cube. I'm just gonna add a plane, it doesn't matter. And I'll just do plane so we can see it. Just to make sure that it's working, if I increase this, it should work. So if I go over here, I turn on wireframe, then I should be able to see my divisions. So yeah, we're going to start with 2 by 2. So that's just a plane. And also another thing that we need to do is show mesh indices. If you don't have this, then you probably don't have the developer tools turned on. So if you go to edit preferences, and then you go to interface, and if you check developer extras, you'll be able to go from here and show the mesh indices. You can also show the edges if you want, but we only need the vertices, and you can change their color if you want. Okay, now we already have the indices. So the next thing that we're going to do is add a script. So you can just go to subprograms and add a script node. Now in your script nodes, you're going to choose your script file, and then you can rename whatever this is. So I'll just also call it recursive subdivision, and we'll add a few inputs. So the first input that I need is the mesh. However, I'm going to be working with bmesh operations, so I'm going to actually add a B mesh as input. And over here, I'm going to convert this to a B mesh. So I'll just search for create B mesh and add it. And now if I want to show it over here, I'm going to have to choose the type B mesh. And if I link it, yeah, we should see it. And then I also want to add X, which is a float value, and another float, which is going to be the Y value. We'll later also add iterations, but we won't think about that right now. And the way you can hook this B mesh to this is if you invoke the subprogram. So what I'll do is just link this over here. And then for the output, because I want whatever is outputted by the script to be shown as the object, so I'll just add a new output, and it'll also be a B mesh. And then this will be hooked over here. And I'll change its name to BM new. What's nice in subprograms over here in the script panel is that you can actually see some of the errors. So whatever you have in your script file that isn't working, it'll show you a small description, and it's very helpful if you look at it. So it says BM new not initialized, so we'll have to actually write it over here. So I'll do BM new equals BM, which is our input. So whatever we have in here as variables, it's already defined and we can use it inside of our script. And now we can start writing our code. So in animation notes documentation, it says that the majority of libraries are already imported. However, BMesh was not. So when I started creating using BMesh, it required me to import it. So I'll just import the library over here, and we'll start by creating a faces list. So we'll create an empty list for each of the faces that we have, and then I'll feed it, or I'll append the BMesh faces, the current BMesh faces, to that list. So I'll do faces, extend BM faces. So the way you can get the BMesh faces is just by getting the BMesh input and getting the faces property from inside of it, or the list. Okay, so the way I do this is using a for loop. So I'm anticipating that I'm going to have to loop through all the faces to cut them out. So I'll just start by doing for F in faces. So for each face in faces, I'm going to do the same exact thing that you saw in Matt Taylor's video. So we'll grab the initial vertices. So here there are 0, 1, 2, and 3. And then we'll create the other 5 vertices in order to create the subdivision, and then we'll create the faces from those vertices. So the first thing I'm going to do is grab whatever is there already, and I'm not sure why it doesn't work the same way, or I have to flip everything, but the way it worked for me is by assigning vertex 3 to position 0. So this acts as 3. And I think I messed something up as I was coding, but this worked for me, so I'm going to just leave it there, but feel free to change it to make more sense. But the way I did it is that I flipped everything the other way around. So for position 0, I actually took the vertex at position 3 for each of the faces, and then for position 1, I did 2. And I'll do the rest. Oh, actually, these are lists, so I'm gonna have to do square brackets. Okay, now we can create or interpolate between the points. So for position A, it's going to be position 0, and we need the coordinates, or we need the vectors. The way we can get that from each vertex, which is of type BM_vert, we're gonna have to use co. So co is basically the coordinates, and it's a vector. And we can use lerp, and I think lerp is from the math utility library. So I'll just use that. And I'm going to lerp from point 0 to point 1. And because that is on the y-axis, which is the green one over here, then it's going to be using the y value. So that will be position 1. And also we'll grab the coordinates and we'll lerp it by y. So we're grabbing the first vertex, lerping it, or interpolating between the first vertex to the second by a certain value, which here is going to be our y value, which is over here. And in order to see this, we're going to have to create the vertex. So I'll just create it so we can see it. So the way you can create a vertex for a bmesh is by just doing bm, which is the variable that I chose, .verts.new, and then you give it the position of that. And we have it over here. Of course, these values are not clamped, so you're going to have to clamp them. You can add a clamp over here. So whatever value I put over here, it's going to be clamped from 0 to 1. Cool, we'll do the same thing for x as well. And then we'll create the other point. So for b, it's going to go from point 1 to point 2. And also, like, I'm going to refer back to Matt Taylor's video a lot because he explains it very well. It works the same for me as it worked for him because he did 0 to 1 and then 1 to 2. So it says 3 over here, but it somehow counts as 2. So this will be over here. So we'll do position 1.co and then we'll lerp that to position 2. And that will be on the x-axis. And if I create this and then I move this, you'll see that it works from 1 to 3. Okay, I'll do the same for C and D. And since for this one we went from 0 to 1, we're going to have to go from this point, which is 3 actually, to 2. So we have to lerp in the same direction, basically because I want this to move the opposite way. So this will be 1 minus y. So whatever y is, so whatever this is, this will be the opposite. So if 4 is over here, then this will be over here. And this will be from point 3, which is this basically, to point 2. And that will be y, 1 minus y. And if I copy this, and I'll just do point C, you can see them working in opposite directions. We'll also do the last one, and the last one will be the same way. So if I started from 1 to 3, then I'm going to lerp from 0 to 3 over here. And that will be x. And I'll have to add that. So we added all the points. So if I move x, now they both, 5 and 7, both move in the same direction. And the final 2 points that we need to create in order to create each of the subdivisions or each of the rectangles inside of our main one, we'll also create position E and position F. So E, F are going to be lerped from or interpolated from 5 to 7. So B to D. Or rather D to B, that's how I did it. So I'm not going to change anything because I don't want to run into issues. So I'll just lerp, and we don't need to use co because these are already vectors and we can just interpolate from D to B, and that will be on the y-axis. And then the same thing will happen for F, but it's going to be the opposite. So 1 minus y, and then we'll add them over here. Now if I move everything, it works perfectly. And now we have 4 polygons. Well, not yet. We'll have to create the polygons, the faces for these points. So let's create those faces. To create the faces, I did the same thing that I did with the vertices. So bm faces.new. But now this takes a tuple. I think that's what it's called. And it takes the 4 vertices that we need in order to create that face. Well, in our case, it's 4 points. And now I have to store these inside of other variables to store these vertices so I can use them over here. So I'm going to just do point A, and I'll copy and paste this. And I'll just change these. So if you notice, this is actually very, very similar to Matt Taylor's code. And now I'll use these points to create the polygons. And because we have wireframe turned on, we'll actually see it. Also, another thing that I did, it's definitely not necessary because who wants to add more variables, is make those or assign those to new variables called point 0 to 3. Just because I was getting confused as I was testing, but I'm not going to do it here because I already know what I need for each face. So for the first one, it's going to be position 0, so this vertex over here, and then it's going to be point D, point E, and point A. So if I run this, or if I change the value for each one of them, you'll see that we have one face already. And I'll do the same thing for all of them. So we'll end up having 4 faces. So for the second one, it's going to be A. And this is where I got confused because I had to change every position to point. And if I needed a position, then I'll need to use that variable. Okay, so for the other one, it's going to be point A, point E. And we're moving clockwise. So I moved from 0 to 4 to 8. Actually, no, it's the opposite. I moved from 0 to 7 to 8 to 4. And the reason for this is because when I showed the face orientation, so to see the normals, I was getting red for this one. So it was the opposite. So it wasn't working well. And I think the reason for this is because I flipped those and I proceeded to do everything flipped. So I had to move in the opposite way. So counterclockwise. Okay, so for this one, it's going to be point A, which is 4, and then point E, which is 8, and then we'll go over here for point B, and then position 1. And then position 1. I'll have to do position over here. And then for this one, it's going to be B to F to C to position 2. This one actually moved the opposite direction. And this one is going to be point. So this went from here, so point B, and then point F, and then point C, which is 6, and then position 2, which is the 3 over here. Honestly, I'm still not sure why I had to move the opposite direction for that one, but I was just checking my normals and trying to flip it and seeing if that works. Position 3 for this one, and point C, then point F. And now if I move it, I actually have 4 polygons or 4 faces, and it works perfectly. Also, if you want to make sure that you're not adding more, you can even go to in the viewport overlays and check statistics just to see how many vertices you have, how many edges, how many faces. So right now we have 5 faces. So this is a great way to debug your code as well. The reason for this is because we have the original grid still there. You can also go to edit mode and you can move everything just so you can check. So you can see that it's still, that face is still there. And the reason why everything is attached is because we're using the same points for some of the faces. And you don't have to even fix it. If you do this, it'll just come back because animation nodes is creating the mesh that we just manipulated over here using the edit mode. So the way I did this is by removing all of the faces. So I just did bm.faces.remove f. So this is going to be removing all of the faces. And before I do this, before I run or touch animation nodes, any of the properties there, because I don't want it to do anything here, I want to append all of these. I'll just comment this out because this caused Blender to crash so many times. So I'll just do the append, which is what I did differently from how everybody is doing it in Houdini, I guess. So the way I do it is I followed Daniel Schiffman's Nature of Code book on recursions. These new faces that we're creating, we're going to save them in a temporary list that you can call whatever you want. We're going to call it next for next generation, and then storing that in the faces list instead of what was there. So I have to create a new array. I'll just call it next, and this will be whatever new faces we create over here. So if I append everything over here into that, so all my new faces are going to be appended, and this is happening outside of the for loop, by the way. So if I go over here, also outside the for loop, I'm going to clear the faces list, and then I'm going to extend this list. So now it's an empty list, and I'm going to extend it with the next generation. And then I will update the index, because for some reason it doesn't update and you have to update the index. Maybe someone can explain this in the comments, but you have to update it because everything inside of the next array has the index of -1. So once you update the index, and then if you print it over here, if you open Blender from the console, then you can see the printed list and you will see the indices of those. So after index update, actually the indices are corrected. And now this whole thing is going to be repeated inside of a function. So I'm going to append everything once because I'll be creating a function. I'll just call it generate. And now all of this is inside of our function. And I'm going to call our function over here. So however many times you want to call the function, or however many subdivisions you want, you iterate that function. So I'll just do for I in range, and I'll just say iterations, and I'll call generate. And then iterations is going to be a new input in our script file over here, or in our script node. So that will be an integer. I'll call it iterations, and then we'll have it 1. So as you can see right now, this is 1 iteration, this is 2 iterations, and so on. I'll also remove this one over here. So what is going to happen is that I'm interpolating the vertices, I'm creating them, and then I'm creating the faces, and then I'm removing whatever old faces there was. And then after I remove it, I'm going to clear the faces array because I don't need it anymore, and I'm going to fill it with my next generation. So if I run this right now and I do 2, I'll go back to 1. I should have 4 faces. But for some reason I still have, okay, so it was inactive. So now I have 4 faces. So everything is working perfectly. And if I move this with 2 iterations, you can see that everything is moving nicely. And let's go to edit mode. And if I move it, you can see that I don't have any faces underneath. So it's working perfectly. So that's basically how I did it for my L in the 36 days of type. But for this tutorial, I wanted to do a little bit more. I wanted to also extrude and bevel the faces, and then I'm going to show you how to color them randomly. The way you can do that is using a for loop, and we're going to just loop through the faces. And you can just grab the material index or assign a value to the material index for each face. And I did it using the random library in Python. So import random, and here I'm going to use random, the random method from there. So random is going to give you a number from 0 to 1, and you have to multiply it by the maximum number that you need. So it's going to be length, and we're going to have to input the object into our script node as well. Object, and then material slots. And because this gives me a float, and for index I'm gonna need an integer, I'm gonna just cast it into an integer. And this will give me a number from 0 to the number of materials minus 1. Okay, it'll complain that we don't have an object if we move anything from here, so I'll just add a new input, which is going to be an object, and I'll just call it obj because I'm calling it obj over here. And then I'm going to use the plane, and I'm going to remove the faces. So now we can go to the materials tab over here, and we can just add a few materials. But now it's going to give me a random number every time this moves. So we have to also add a random seed. So I'm gonna just put it up here. So we'll use the seed method, and you can make this a value over here. So I'm gonna actually make it an input. So we can just do integer, and I'll call it seed, and we'll just call seed over here. Now we can change the seed. So if I move this right now, we still have the same colors. Lastly, we're going to extrude this, and it's very easy to do that. I'm going to use bmesh operations in order to do that, and that's bmesh ops, and in there you can find lots of methods. I chose to extrude the faces, so it's to extrude discrete faces. Okay, and then we're going to use rbmesh for the first argument, because you have to specify what mesh you want to extrude. And then for the second one, it's going to ask for the faces, so which faces you want to extrude. So I'm going to do bm faces, and you have to give it a keyword for the other argument. So it's faces equal bm.faces. Now if I move this, you can see the numbers are actually increasing because now we have actually more faces. But with extrude, for some reason I didn't realize that I was extruding and moving the whole time when I extruded anything when I'm modeling. But I realized it when I coded this. So if I go to edit mode, and then I move it by pressing G, and then I just move it up, you can see that we have new faces or polygon sides right now. So we know that it extruded it, so it's working. Let's just reset this. But we need to move it. So the way you move this is just going through the faces. So I'm going to loop through the faces, and it's going to be through the extruded faces. I don't want it to loop through everything. So I'm going to just call this extruded, so I can just grab the mesh or the geometry from inside of it. So extruded, and then I'm gonna grab the faces. So looping through the extruded faces, I will translate those faces upward, or along the normal basically. And it's also inside of it, the bmesh operations, so it's going to be translate, again bmesh, and then it's going to be, or it's going to ask for the vertices, so I'm going to just do f verts. So I'm grabbing the vertices inside of our faces, or each of our faces, and then the vector is basically the amount that you need to translate. For this one, I did 0.02 and then multiplied by the normal. I'll show you first what you can do without this so I can explain it. So this basically is a vector that goes like this. So it has x, y, and z. So if I want to move it upward on the z-axis, then I'm going to do this. If I do this right now, it's actually extruding. Let's actually do it 1. Okay, so as you can see, it translated it upward. However, if you have a cube or any other shape that has rectangular faces that you want to use this on, this will not work because it's not extruding along the normals. It's just extruding along the z-axis. in order to translate it on each normal, then you're gonna have to do the value that you want to extrude by, and then multiply it by the face's normal. So the face's normal is already a vector, so we're multiplying a value by that vector. And if I do this, then we have the same results. So now we're assuring that if you have a cube over here instead, that it's not going to extrude everything, even the sides, to the top or upward. It's going to extrude it along the normal. And then lastly, we're going to bevel. So that also uses the operations inside of the bmesh class or library. And then I'm going to call bevel. It takes a bmesh, and then it takes a geometry. It'll be each face edges, and then we need an offset. So offset, I'll offset by 0.1 for now, and then we'll adjust it later. And then I'll do effect, because in the documentation, if you look at that, then you'll see that effect is where you choose whether you want to bevel edges or vertices. So I'm doing edges, and then how many segments do you want? If you use the bevel, you know these, you know how to use all of these arguments. So I'm going to do 3. And then you have to also adjust the profile or set the profile. The reason for this is because if you bevel without setting the profile, the default is 0 and it'll bevel inward. So if you set this to 0.5, it'll do the exact same thing that it does when you bevel using the modeling tools inside of edit mode. So I'll just do 0.5, and then I always like to clamp overlap. So I'll set that to true, as it's a Boolean. And then for the last one, let's not set it right now, and I will show you what happens. So if you look, you can see the bevel has a different material. It's grabbing the first material from the list of material slots that we have. In order to fix this and get the material of its face, or the edges face that we're trying to, the edges from the faces that we're trying to bevel, we're going to have to do material, and we'll do -1. And now each one of them have the material of its face. So you can see now, if I hide this, you can see that everything is visible. When before we didn't have the bevel and extrude, even if we had the extrude, if we don't have the bevel, then you only see the colors and it doesn't really look nice. So what's cool about this is now you can add modifiers to this. So if I go to simple deform, then this, I can shape this to whatever I want and it still works. And you can shade it with any renderer as well. I shaded this one, the example that I created in the intro, using Octane, but I used Eevee for the one I have on Instagram for the letter for the 36 days of type challenge. Oh, and by the way, the way I did the, if you want to put this on a cube, you can just create a cube and reference it over here, and then it'll do the same thing. So if you just create a cube, and let's scale it up. You can hide this right now. I think it's mesh from objects. And then if you do mesh from objects and you select the cube, you can just connect that to here, and we can show this and hide the cube. And you can see that it's extruded, so you can make the extrude or translate the extrude a little bit less. And now you have a cube. And you can also animate it. So the way I did that is by adding an animate float. So I don't need these anymore. So I'm gonna just put them over here. And I did one for each, X and Y. And I did repeat time, and I chose ping pong. And then I added a frame. The start value is going to be 0 and the end value is going to be 1 for each of those. And if I go to animation and I move this, then it moves. So if I hit play, and you'll have to adjust the values, of course, because here the rate is 50 and then the duration is 20. I think I made them all 20, something like that. Let's play this. This is pretty much all you need to know about how to create animated recursive subdivisions. And please do tag me with anything that you create on Instagram, and like and subscribe to my channel if you want more tutorials. And if you have tips for how to better this, then please share it down in the comments below so everybody can see it and try it. Thank you so much for watching this, and talk to you next time.